Lesson 8.1, applying exponent properties involving products. Alright, this is a little bit different than what we've been used to. It seems like for so long we've been dealing with the graphing and slope-intercept form, standard form. And starting with this chapter, we're not going to be graphing for a while. So, kind of clear your head from the whole graphing scenario. And let's discuss exponent properties. Okay, but first let's review, what are exponents? If I write 5 squared, most of y'all can tell me that the 2 is called the exponent. That is also known as the power. Okay? And then this big number, the 5, is called the base. Alright, so what exactly does 5 squared or 5 to the second power mean? That doesn't mean 5 times 2. This exponent tells you how many times to multiply the base. So it really becomes 5 times 5. Okay? So a short way of writing 5 times 5 would be 5 squared. Well, where did we get this squared from? Because really, looking at this, I don't see a 2 anywhere. Other than though I'm multiplying the same base. Okay? Anytime you have a number, there's always an imaginary exponent of 1 with it. Even though we don't write it, it's there. But this leads us to the product of powers property, which states that to multiply powers having the same base, you add the exponents. So, here we have 5 times 5. I know there's an imaginary exponent of 1. I can see that I'm multiplying. I'm multiplying like bases, therefore I'm going to add the exponents. So that's going to become 5 to the 1 plus 1, which gives me 5 squared. Okay? Now there is a difference between addition and multiplication. So you know that A plus A gives me 2A. That's if you're adding. But if I'm multiplying A times A, the difference between addition and multiplication is that when you're multiplying like bases, you add the exponents. So that's going to become A squared. That's why we have to determine, are we adding or are we multiplying? Because if we're doing either or, it's a whole different process. Right, here I have A to the M times A to the N. I am multiplying like bases, so I'm going to add their exponents, so that becomes A to the M plus N. And then so on with the next example. Multiplying like bases, you add exponents. Okay, right now I'm recording the lesson. Right, there you have 5 to the 6th power times 5 cubed. I can see that I'm multiplying like bases. So that's going to become 5 to the 6 plus 3, which gives me 5 to the 9. Okay, let's try a few examples. Alright, let's do 4 to the 4th times 4. I can see that I'm multiplying and I have like bases. So what do I do with their exponents? I have to add. So I'm going to have 4 to the, remember there's that imaginary 1 there. So 4 to the 4 plus 1 gives me 4 to the 5th. And then let's look at D. Okay, the first thing I ask myself is, what am I doing? I have negative 6 times negative 6 to the 6. You heard me say times, so I break it apart to be a product. And I'm going to keep this negative 6 inside parentheses because that's where it started off. So I'm going to have negative 6 times negative 6 to the 6th. Alright, again, I am multiplying like bases. So what do I do with their exponents? That becomes 1 plus 6, which leaves me with negative 6 to the 7th. In this bubble over here, it says when simplifying powers with numerical bases only, numerical base, write your answer using exponents. Alright, power of a power. Second property, power of a power property. To find a power of a power, you're going to multiply exponents. Okay, well, what does a power to a power look like? It's kind of like this. You can see I have a to the nth power, but then I have to the nth power. Alright, well, when you have a power to a power, you're going to multiply the exponents. So that's going to become a to the m times n, which gives me a to the mn. Using numbers, I can see I have a power to a power. So that's going to give me 3 to the 4 times 2, which gives me 3 to the 8th power. Let's try B. I have n to the 7th power to the 2nd power. Power to power. Therefore, I'm going to multiply the exponent. It's going to give me n to the 14th. Look at C. Do not let all these brackets and parentheses confuse you. A bracket is the same thing as a parentheses. We use parentheses when we want to keep something as a group. So, you can see I have negative 3 inside parentheses. That means I want to keep the negative with the 3. So, I'm going to keep it inside parentheses. Here I have a power to a power. 5 times 3 gives me 15. Then look at D. I have z minus 4 to the 2nd power to the 5th power. Again, these parentheses just mean we're going to keep z minus 4 as a group. So I'm going to have z minus 4, power to a power, I multiply exponents. Alright, and our last property is power of a product. If I give you AB, and I'll tell you to write that as a product. Product means we're multiplying. So it's going to become A times B. Okay? To find the power of a product, we're basically just going to distribute that power. We have to distribute it to each factor. So I'm going to change what's in parentheses to look like a product. Okay? So now I have this power, so I have to distribute it to each factor. So that's going to become A to the M, B to the N. Same thing here, I have a product. I'm going to take this exponent and I've got to distribute it to each factor. So that becomes 23 to the 5th times 17 to the 5th. That's the power of a product. So let's practice using that property. I'm going to do B and C with you. The first note says, When simplifying powers with numerical and variable bases, go ahead and evaluate the numerical power. So when you're dealing with numbers and letters, evaluate the numbers as far down as they'll go. On B, I have negative 3RS squared. Well, here's parentheses. That means I want to keep it as a group. The negative is inside the parentheses, so I'm going to keep it with the negative 3. And to remind myself that all of this is involving multiplication, I'm going to break that down to be negative 3 times R times S. Here, I have a product of, or power of a product. So I have to take this power and distribute it to each factor. Okay, so I'm going to have negative 3 squared times R squared times S squared. I distributed this power to each factor. And I kept the negative 3 inside parentheses. Again, if you're using your calculator to find negative 3 squared, keep it in parentheses. So negative 3 times negative 3 gives me positive 9. R squared, S squared. Look at B. I can see that the negative is outside the parentheses, so I'm going to keep the negative outside. I'm going to break that down to be 3 times R times S squared. So I'm going to take this power and I'm going to distribute it to each factor. Keep the negative outside parentheses, so I'm going to have 3 squared, R squared times S squared. Drop down my negative. Now what is 3 squared? It's 9. Then I have R squared, S squared. Okay. Alright, let's do a few checkpoints so I can make sure y'all are getting it. I didn't do the checkpoints on the notes in the classroom. Therefore, I'm doing it on this video so y'all can have some extra guidance if you need it. Okay, number 1. Simplify the expression. I can see I'm multiplying. I'm multiplying like bases. Therefore, I add the exponents. So 8 plus 5 is 13. Number 2. There's an imaginary 1 there. I'm multiplying like bases. So that's going to become k to the 3 plus 1 plus 2, which gives me k to the 6. Power to a power, we multiply exponents. So that's going to become p to the 3 times 4, which gives me p to the 12th. Again, inside these parentheses, I can't do anything, but I do see I have a power to a power. So I'm going to keep the q plus 8 as a group. Power to a power, we multiply exponents. So that's going to become q plus 8 to the 12th. Number 5, I have 8 times c times d, and all of that is squared. Power of a product, I have to distribute this power to each factor. So that's going to become 8 squared, c squared, d squared. 8 squared is 64, so I have 64 c squared, d squared. It is now simplified. Number 6, I have the negative on the outside of the parentheses, and then I have 5 times z cubed. Power of a product, I have to distribute this power to each factor. I'm going to have negative parentheses 5 cubed times z cubed. So negative, what is 5 cubed? Negative 125 z cubed. Alright, example 4. Working a problem using all 3 properties combined into one problem. I'm going to do it over here where I have more room. I'm not going to do anything with the x squared or the multiplication, so I'm just going to drop it down. I can see I have 3 times x cubed times y, and all of that is cubed. Again, I'm going to bring down my x squared and my multiplication sign because I'm not doing anything with them yet. But I can see I have this power and I have a product. I have multiplication in here. Therefore, I have to distribute this power to each factor. So I'm going to have 3 cubed times x cubed cubed times y cubed. Right, let's simplify. I'm going to have x squared times 3 cubed is 27 times power to a power. I multiply exponents, so I'm going to have x to the 9th times y cubed. Okay, we're getting there, but we're not completely simplified because I can see that I have x squared and x 9 and I'm multiplying. I'm going to have 27. Multiplying like bases, I add the exponents. So 2 plus 9 is 11, and then y cubed. Alright, let's do these 2 checkpoints. Again, I did not do these in class, but I'm going to do them here on this video. So in parentheses, I have 2 times x to the 5th to the 4th. Power of a product. I have to remember, I can't just go 5 times 4 and be good. I have to distribute this to each one. So that's going to become 2 to the 4th times x to the 5th to the 4th. What is 2 to the 4th? Power to a power, I multiply exponents, so that becomes x to the 20th. Alright, number 8, I have 3 times y cubed to the 4th times y to the 5th. Power of a product, so that's going to become 3 to the 4th times y cubed to the 4th times y 5th. 3 to the 4th gives me 81. Power to a power, I multiply exponents, so that's y to the 12th times y to the 5th. Okay, again, I can see I have multiplication and I'm multiplying like bases, so I'm going to have 81. When you multiply like bases, you add exponents, so 12 plus 5 is 17. And that's lesson 8.1, applying exponent properties.